Next, we're going to talk a little bit about data warehousing, and this is a field that's really been upended recently by the advent of Hadoop and some big data techniques and cloud computing. So a lot of big buzzwords there, but concepts that are important for you to understand. So let's dive in and explore these concepts. Let's talk about ELT and ETL and data warehousing in general. This is more of a concept as opposed to a specific practical technique, so we're going to talk about it conceptually, but it is something that's likely to come up in the setting of a job interview. So let's make sure you understand these concepts. Let's start by talking about data warehousing in general. So what is a data warehouse? Well, it's basically a giant database that contains information from many different sources and ties them together for you. So for example, maybe you work at a big e-commerce company and they might have an ordering system that feeds information about the stuff people bought into your data warehouse. And you might also have information from web server logs that get ingested into the data warehouse as well. And this would allow you to tie together browsing information on the website with what people ultimately ordered, for example. Maybe you could also tie in information from your customer service systems and measure if there's a relationship between browsing behavior and how happy the customers are at the end of the day. So a data warehouse has the challenge of taking data from many different sources, transforming them into some sort of schema that allows us to query these different data sources simultaneously, and it lets us make insights through data analysis using these disparate data sources. So large corporations and organizations have this sort of a thing pretty commonly. We're getting into the concept of big data here, right? And you can have a giant Oracle database, for example, that contains all this stuff. Maybe it's partitioned in some way and replicated and all sorts of complexity there. And you can just query that through SQL, structured query language, or through tools. Graphical tools like Tableau is a very popular one these days. And that's what a data analyst does. They query large data sets using stuff like Tableau. And that's kind of the difference between a data analyst and a data scientist. You might be actually writing code to perform more advanced techniques on data that border on AI, as opposed to just using tools to extract graphs and relationships out of a data warehouse. And it's a very complicated problem. At Amazon we had an entire department for data warehousing that took care of this stuff full time, and they never had enough people, I can tell you that. It's a big job. There are a lot of challenges in doing data warehousing. One is data normalization. So you have to figure out, how do all the fields in these different data sources actually relate to each other? And how do I actually make sure that a column in one data source is comparable to a column from another data source and has the same set of data at the same scale using the same terminology? How do I deal with missing data? How do I deal with corrupt data, or data from outliers or from robots and things like that? All very big challenges. Maintaining those data feeds, also a very big problem. A lot can go wrong when you're importing all this information into your data warehouse, especially when you have a very large transformation that needs to happen to take the raw data, say from web logs, into an actual structured database table that can be imported into your data warehouse. Scaling also can get tricky when you're dealing with a monolithic data warehouse. Eventually your data will get so large that those transformations themselves start to become a problem. And this starts to get into the whole ELT versus ETL thing. So let's first talk about ETL. What does that stand for? It stands for extract, transform, and load. And that's sort of the conventional way of doing data warehousing. So basically, first you extract the data that you want from the operational systems that you want. So for example, I might extract all of the web logs from our web servers each day. Then I need to transform all that information into an actual structured database table that I can import into my data warehouse. So that transformation stage might go through every line of those web server logs, extract transform that into an actual table where I'm plucking out from each weblog line, things like session ID and what page they looked at and what time it was and what the referrer was and things like that. And I can organize that into a tabular structure that I can then load into the data warehouse itself as an actual table in a database. So as data becomes larger and larger, that transformation step can become a real problem. Think about how much processing work is required to go through all of the web logs on like Google or Amazon or any large website and transform that into something a database can ingest. That itself becomes a scalability challenge and something that can introduce stability problems to the entire data warehouse pipeline. So that's where the concept of ELT comes in, and it kind of flips everything on its head. It says, well, what if we don't use a huge Oracle instance? What if instead we use some of these newer techniques that allow us to have a more distributed database over a Hadoop cluster? And that lets us take the power of these distributed databases, these things built on Hadoop like Hive or Spark or MapReduce, and use that to actually do the transformation after it's been loaded. So the idea here is we're going to extract the information we want as we did before, say from a set of web server logs, but then we're going to load that straight in to our data repository. And we're going to use the power of the repository itself to actually do the transformation in place. So the idea here is instead of doing an offline process to transform my web logs, as an example, into a structured format, I'm just going to suck those in as raw text files and go through them one line at a time using the power of something like Hadoop to actually transform those into a more structured format that I can then query across my entire data warehouse solution. So things like Hive let you host a massive database on a Hadoop cluster. And there's things like Spark SQL that let you also do queries in a very SQL-like, data warehouse-like manner on a data warehouse that is actually distributed on a Hadoop cluster. There are also distributed NoSQL data stores that can be queried using Spark and MapReduce. And the idea is that instead of using a monolithic database for a data warehouse, you're instead using something built on top of Hadoop or some sort of a cluster that can actually not only scale up the processing and querying of that data, but also scale the transformation of that data as well. So again, you first extract your raw data, but then we're going to load it in to the data warehouse system itself as is, and then use the power of the data warehouse, which might be built on Hadoop, to do that transformation as the third step. Then I can query things together. So it's a very big project, very big topic. Data warehousing is an entire discipline in and of itself. And we're going to talk about Spark some more in this course very soon, which is one way of handling this thing. There's something called Spark SQL in particular that's relevant. Also things like Hive, MapReduce, big data techniques in general that are more modern that we can cover. And there are other courses that I offer on Spark and MapReduce that will give you more insight into this. I also have a free course on big data basics you can check out. But lots to learn about there. So again, the overall concept though is if you move from a monolithic database built on Oracle or MySQL to one of these more modern distributed databases built on top of Hadoop, you can take that transform stage and actually do that after you've loaded in the raw data as opposed to before. And that can end up being simpler and more scalable and taking advantage of the power of large computing clusters that are available today. So that's ETL versus ELT, sort of like the legacy way of doing it before we had a lot of clusters all over the place in cloud-based computing versus a way that makes sense today when we do have large clouds of computing available to us for transforming large data sets. That's the concept. So again, ETL, kind of the old school way of doing it. You transform a bunch of data offline before importing it in and loading it into a giant data warehouse monolithic database. But with today's techniques with cloud-based databases and Hadoop and Hive and Spark and MapReduce, you can actually do it a little bit more efficiently and take the power of a cluster to actually do that transformation step after you've loaded the raw data into your data warehouse. So this is really changing the field, and it's important that you know about it. Again, there's a lot more to learn on this subject, so I encourage you to explore more on this topic, but that's the basic concept, and now you know what people are talking about when they talk about ETL versus ELT.